Hello grade 12s, today we're going to be doing some revision and we're going to be focusing on maths literacy and calculations with numbers. Let's first of all start by looking at the checklist of things that you need to know before we start revising. You need to know how to work with fractions, decimals and percentages. As part of this, you need to be able to identify parts of fractions and decimals. You also need to be able to add, subtract, multiply and divide these decimals, and remembering the key of BODMAS rules. We will also be looking at increasing and decreasing by fractions and decimals and percentages, and comparing using fractions, decimals and percentages. You will need to be able to work with ratios and work with large and small numbers. This is a very important one, being able to convert units of measurements. There are some key ones that you need to learn and others that will be given to you, but we'll talk about those in some of the examples. You will need to be able to convert different currencies given the exchange rates, and one that most people find very difficult is being able to work with time and be able to convert between the different parts of time. In basic data handling, this includes your graphing, this includes your averages, being able to compare data, being able to do different things with the data, and then being able to come up with a comparison if necessary. In this section, you need to be able to explain how to work with the best value for money. So they might give you different examples of different values of things, and then you would need to decide which would be the best option to buy if you were purchasing it and wanted to buy the cheapest goods. You need to also be able to convert into different foreign exchanges and then also be able to comment or use those different areas of foreign exchange. Another thing you need to be able to do is to actually being able to work with averages. This would be your mean, mode, and median. You would then have to be able to decide which is the best option for the different scenarios and also be able to comment on these. And then the part that everybody finds difficult is solving problems, and that's what we're going to be doing later on as well, looking at some examples of solving problems. You need to be able to solve problems using ratios, fractions, decimals and percentages, and foreign exchange and money, and of course our favorite, probability. Let's now look at some examples, and let's see how we would actually go about answering them in the best possible way. Let's start off with a few easy ones to start with. Now, I'm going to be focusing on the fact that you might not have a scientific calculator. If you have a scientific calculator, obviously it's a lot easier to actually do this because you can then just plug it in and it looks identical to this in your calculator. So if I pulled up the calculator, it would then tell me step by step. I could just type this in with the brackets and put my fraction in and push the equals button. So then it's not very, very difficult. What I want to focus on is that if you didn't have a scientific calculator, how would I then go about doing this? And this is where we need to remember our friend BODMAS. B stands for brackets. This one stands for order, which is basically your power. if it was to the power of 2 or something else. This one would be divide, multiply, add, or subtract. So in this situation, I would look and see, oh, I've got brackets, so I'm going to do this part first. If I had to type this onto my calculator, I would type it as 3, and I don't have an over button as for a fraction on my basic calculator, so I need to remember that the 4, if it's 3 over 4, it means 3 divided by 4, and then times by 16. And I would do that part first. Then I would add, then it'd be 0,05 times 235. And again, timesing comes before adding, so therefore this part would be done next. So let's get out our calculator and do this first bit. So let's do 3 divided by 4 times 16. And that gives us 12. And then I need to do this part. So I'm going to clear my calculator and do 0.05 times 235. And that doesn't give us a very nice answer, so I'm going to do it in decimal form, and that gives us 11,75. When I add these two together, if I add 12 and 11,75, I will get 23,75 as my final answer. Okay, let's go on to question 1.2. Now, when we're talking about percentages, we need to remember that a percentage basically means divide by 100. So what I could do is write my 35% as 35 over 100. Of always means times, and then we've got 2,405 Rand. So I would then get up my calculator. I would then say 35 divided by 100 times by 2405, and make sure it's in decimal form so I can write it as money, and should give me 841 Rand and 75 cents. Please always make sure that money has only got 2 decimal places. Right, let's go on to 1.3. If 5/8 of a pizza was eaten, what fraction is left? Now, if I can imagine my pizza and I cut it into 8s, and I've eaten 5/8, it would be very easy to then see I've got 3/8 left. But how would I do this on a calculator, or how would I do this when I actually haven't got an easy number, for example? Just remember that if I've got a whole, it's 1, and I'm minusing the 5/8. 1 can be written as 8 out of 8 because I've got 8 pieces when I start off with. And then I'm taking away 5 eighths. And because I'm subtracting decimals, or fractions should I say, it should have the same denominator. So I'm going to keep the 8. And then 8 take away 5 is 3. So that's where we would get the 3/8 from. And that's the end of question 1. Okay, so let's now look at question 2. Question 2, the first one is to write 3.5 million in full, which means that that needs to be in numbers. When I see the word million, it suggests that it should have 6 zeros. Just be careful because there is a decimal place there, which then suggests that you need to actually have that 5 included in those zeros. So the best way of doing this is to actually say 3,5 times 1 million, which has the 6 zeros. And if I do this on my calculator, I will never get the wrong answer because it should be 3,500,000. Right, now we go on to your favorite ones, to convert from meters to centimeters. Now this is quite an easy one, but you do need to remember that you do need to know all the conversions. So you need to know that 1 meter is equal to 100 centimeters. And there's a lot of others that you need to know as well, like 1 kilometer is equal to 1,000 meters, and 1 centimeter is equal to 10 millimeters. There's now lots and lots of those. I would suggest that you make sure that before you go into your exams that you actually have learnt those, because those are not going to be given to you and you do need to have those ready in your brain to use. So we want to go from meters to centimeters. And I now know that 1 meter is the equivalent of 100 centimeters. So I now need to convert 3,5 meters. And I always find the easiest is to do it as a ratio. I'm going to times this by 3,5. So therefore I need to times this by 3,5. And if you can do it without a calculator, you will know that it's 350 centimeters. If you're not that sure about it, please do use your calculator so that you do get the correct answers. Right, the next question. It says, how many bread rolls are there in 4.5 dozen? Now, dozen is a word that all the examiners are presuming that you know. You need to know that that is 12. So this could be related to eggs, this could be related to bread rolls, this could be related to a few other things. So they could be asking you similar types of questions. So that's something you need to learn. Obviously then, half a dozen will be equal to 6. So if I had half a dozen bread rolls, it would be 6 bread rolls. If I had half a dozen eggs, it would be 6 eggs. So now if I've got 4.5 dozen, I would say 4 times 12, which hopefully you all know is 48. And I've got half a dozen, which is 6. And if I add those two together, I should get 54 bread rolls. Right, 2.4. The next one is to decrease 5 kilograms by 15%. Now there's a few ways we can do this. We can either find out what the 15% is and then subtract it off, or we can convert the decrease part into a percentage and times it by that. So let's do method 1. So I'm going to do method 1. Okay, I'm going to find out what 15% of 5 kilograms is. Please be sure to show all of your working, because this is where you can also get easy marks if you make careless mistakes. To do this on the calculator, I can say 15. If I've got a scientific calculator, I can say use the percentage button, but if I didn't, I would just divide that by 100. So it would be 15 over 100 times 5. And that gives me 0.75 kgs. Now that's not my final answer. I need to decrease it by the 15%. So therefore I need to say my 5 kgs minus 0.75 kgs, and I should get an answer then of 4.25 kgs. Now that's method 1. Most of you will feel comfortable with doing that because that's probably the most basic way of doing it. Some of you would like a quicker version, so this is method 2. What you could say is that if I've got 100% and I'm decreasing it by 15%, I'm actually ending up with 85%. That means that if I've decreased 5 kgs by 15%, I've actually got only 85% of the 5 kgs. So if I find out 85% of the 5 kgs, I will end up with exactly the same answer of 4.25 kgs. I would recommend this method as the method of choice because I think a lot of you need to get all these method marks, that you would be getting method marks for finding out that as well as the subtraction. So I think that this would be the certain one to use. If you are a bit more confident and you would like to try one that's using a little bit more sophisticated methods, this would be the quicker method to use. Right, question 2.5. Write the decimal 12.125 as a mixed fraction in its simplest form. Now, the word mixed fraction basically means that I need to convert this decimal to being a fraction that has got a whole number and a fraction. So if I had to take 12.125, this is my decimal part, and this is my whole number. So this would be 12, and then 0.125. Now I need to convert this to a fraction. I know that 0.125, because it's got 3 decimal places, is out of 1,000. So it would be 125 out of 1,000. And I could write my answer as 125 over 1,000, except that they've told me to convert it to its simplest form, and that's not the simplest form. So therefore, I would then have to divide the top and the bottom of this number to get to my simplest form. I would maybe start with dividing by 5. So it's probably easiest on your calculator. So 125 divided by 5 is 25. And remember, whatever I do to the top, I need to do to the bottom. So 1,000 divided by 5 is 200. This still is not in its simplest form, so I need to divide again. So I'm going to then divide it again. So this is going to, let's try divide. I know that these two can be divided by 5. So 25 divided by 5 is 5. And 200 divided by 5 is 40. Still not in its simplest form, so I'm going to then divide them by 5 again. So it's 12, 5 divided by 5 is 1, and 40 divided by 5 is 8. So that is it in its simplest form. If you're lucky enough to have a calculator, it's a good idea to maybe test that you've got the correct answer. So if I've got 12 and 1/8, I can do 12 and then add on the 1/8. And if I push equals and then the S to D button, it will give me that answer that I've got, the 12,125. And that's what I had to start with. So now I know that my answer is correct. Right, now let's go on to question 3.5. Question 3.5 is dealing with time. A lot of you find that time is quite a difficult quantity to work with, especially when it comes to converting between hours and minutes, minutes and seconds, etc. I think the most difficult part is that it is because that hours and minutes don't have 100 in them, so you have to remember that you need to times and divide by 60 sometimes. So let's go and have a look and see if we can work out this one. Right, we need to convert 5,3 hours to hours and minutes. Now often when I've got a problem and I've solved it, it comes out with an answer like 5,3 hours. Now most of the time the examiners are expecting us to have an answer in hours and minutes. And 5,3 hours is only hours. It doesn't have a minutes component. So when I've got 5,3 hours, this means it's 5 hours and 0,3 hours. So the 5 hours part is fine. It's this 0,3 hours that is the problem. And I need to now convert this to be minutes. Remembering that there are 60 minutes in an hour, I need to then, in order to convert this from hours to minutes, I'm going to times this by 60. So I would get my calculator out and say 0,3 times 60 . 0.3 times 60 equals 18. So that makes 18 minutes. So my whole answer then is that 5,3 hours is equal to 5 hours and 18 minutes. Right, let's have a look at the last question for question 2.7. Let's go down a bit so that we can actually see this clearly. Right, we need to simplify the ratio of 14 to 182. Always start by writing down your ratio. And the idea is to make this as small as possible. What you always need to remember is that what you do to the one side, you have to do to the other, and in order to make it smaller, we always divide. Now, because they both end in even numbers, I know that they are divisible by 2. So I'm going to start off by dividing by 2. So if I said 14 divided by 2 will give me 7. And if I halve 182, I will get 91. Now, those numbers I'm not very comfortable with. So I'm going to get out my calculator and see, because 7 is a prime number, I'm hoping that 91 can be divided by 7. So I'm going to try in my calculator to divide 91 by 7. So let's go 91 divided by 7. And that gives me 13, which is wonderful, because that means that if I say 7 divided by 7, I get 1, and 91 divided by 7, I get 13. And that's as simple as I'm going to get. I do not want to go into decimals. This needs to be a whole number when I'm talking about simplifying it to its lowest common ratio. So my first step was dividing by 2, and my second step was dividing by 7. Remembering that both sides need to be able to be divided by the same thing. They have to be divided by the same. Divide both sides by the same number. And that's the end of question 2. Shall we take a break so your brains can recover? Welcome back. Let's try question number 3. This question deals with a combination of time and ratio. So let's have a look and see if we can solve this problem. These ones are slightly more difficult because they are expecting you to do a little bit of problem solving. So let's read it together. It takes Joe 21 minutes to run 3 kilometers. How long will it take him to run 15 kilometers if he runs at the same pace? Give your answer in minutes and then convert this to hours and minutes. So there's quite a few parts to this. So let's start off first of all by finding out how long it's going to take him to run 15 kilometers. I always start off these types of questions with a ratio. So I know that 3 kilometers is going to take him 21 minutes. I would suggest that you find out how long it's going to take him to run 1 kilometer. So I could do this by saying 1 kilometer. And in order to work out that, I'm just going to divide it by 3. Because 3 divided by 3 is 1. And this is a lovely number, so that I can also divide this one by 3. And 21 divided by 3 is 7 minutes. Okay, so I know that he's going to take 7 minutes to run 1 kilometer, and I need to find out how long it's going to take him to run 15 kilometers. So I'm going to change this to be 15 kilometers. And I know that I'm going to have to say 1 times 15 to get to 15. And I'm going to say 7 times 15 over here. So let's get out my calculator because my brain hasn't been able to process that by itself. So I'm going to say 7 times 15. That gives me 105 minutes. Now I know that this is more than 1 hour. How do I know that? I know this because I know that there are 60 minutes in 1 hour. So one method is that I could say, okay, 105 minus 60 is equal to 45, which then means that this is 1 hour and 45 minutes. So that's one method. Another method is to say 105 divided by 60. Why am I dividing by 60? We're dividing by 60 because there's 60 minutes in 1 hour. If I do this on my calculator, lucky I've got my 105 already there, divided by 60. And this gives me 1,75. Now please note, it's not the same as this answer. Reason being, remember the question that we did in question 1? This is 0,7 hours. So this is not in hours and minutes yet. We've still got to carry on. So I need to say, okay, this is going to be 1 hour and 0,75 hours. And remember, how did we convert this before? I need to times this by 60. So let's go back to our calculator and say 0.75 times 60, and we get 45. So that gives us 1 hour and 45 minutes, which is the same as this answer. So therefore, I know that I'm correct. So can we go back and look at this question? Have we answered it? It's very, very important at this point when we're doing problem solving to make sure we have answered the question that they've asked us. They've asked us to find out how long it takes him to run 15 kilometers. We did that. We found out it was 105 minutes. And then we needed to convert this to hours and minutes. This answer would not have been acceptable because it was in hours only. We needed to have hours and minutes. Let's go on to question 3.2. Now, question 3.2 is dealing with comparing prices. This is a very useful skill in the real world so that you can actually make sure that you're getting the best value for money. So let's have a look at this question. There are 3 containers of coffee, 1 kg jar, which is 53 Rand 50, a 2 kg jar, which is 105 Rand 50, and a 750 gram jar, that is 36 Rand 50. The question then asks, what is the cost per gram of each jar of coffee, and then which jar is the best value for money? Now, they've asked us to actually compare these. So therefore, they've told us that we need to convert it to cost per gram. Cost per gram, whenever I look at something that says cost per gram, I then try and translate that into what does this mean in English and convert it to what does it mean in maths. Cost, well, when I'm looking at these examples, the cost is rands. Per always means divide, and then grams. So I need to say whatever they've given us as rands and divide it by grams. What you will notice though is that not all of these are in grams. So therefore I need to look and see that 1 kg is not in grams. So I need to say 1 kg, which should be stored in my head as well, is equal to 1,000 grams. Therefore, in this situation, 1,000 grams is equal to 53 Rand 50. This one is 2 kilograms, so that would be 2,000 grams is equal to 105 Rand 50. And this one we don't need to convert, it's 750 grams is equal to 36 Rand 50. Now I need to now change those to be cost per gram. So let's do our calculations. My 1 kg jar, my cost per gram is going to be my cost. What is the cost of this? Is 53 Rand 50. And I'm going to divide it by 1,000. This will give me 0,0535. Then I go on to my 2 kg jar, which is exactly the same calculation, but obviously with the different numbers. And the cost of the 2 kg jar was 105 Rand 50. And I'm going to divide that by 2,000. And that should give me an answer of 0,05275. Then my last one is the 750 gram jar. The cost per gram is going to be 36 Rand 50 divided by 750. And this gives me an answer of 0,04867. Right, now is this the end of my answer? I've now calculated the cost per gram of each jar. So I've done this part, and that would probably give me my 3 marks out of the 4 marks. I need to now find which is the best value for money. Now, generally speaking, best value means the lowest price. Just remember that this has to be the lowest price per gram, and that's obviously why they've asked us to convert all of these things. I now need to compare these 3 values and decide which is the lowest. Hopefully, you are all able to identify that this is the lowest, and I suggest you write a sentence that the 750 gram jar is the best value for money. And that would be my 4th mark in that question. Right, shall we go on to 3.3? In question 3.3, we are dealing with exchange rates. Often we are required to compare things that are bought in different countries, and that means that we're dealing with different currencies. In this question, for example, we're dealing with the South African Rand and the UK Pound, and we need to be able to actually then compare the 2 different things. In order to compare anything, it is always best to be able to compare that they actually are in the same units. So we've got a choice here. We can either convert from pounds to rands or from rands to pounds. But whatever we do, we need to make sure that we're converting in the same direction. So let's read this question and see which is going to be the best option for this. Tim wants to buy a song via iTunes. The current exchange rate is £1 to 14 Rand 50. The price of a song that he wants to download in the South African store is 8 Rand 99, and the same song in the UK store is 79p, or £0.79. Which is the better iTunes store to use? Show your working to validate your answer. Okay, so in order to compare, as I said before, we need to make sure that we're dealing with the same units. I'm going to convert the rands to pounds so that we can see the difference there. If you would like to do it the other way, those answers are in the answer sheets and you can check that you've done it the correct way then. Okay, so let's have a look. I always like to start off writing the exchange rate. So £1 is the equivalent of 14 Rand 50. And I'm buying a song that is 79p. In order to get from here to here, I'm going to have to times by 0.79. And what I do to the one side, I do to the other. If I get my calculator out, let's do that. So I'm going to say 14.5 times 0.79 and I then get an answer of 11 Rand 455. What is wrong with this answer? Can we have 3 decimal places for money? No, so we need to actually convert that to be 11,46, rounded to 2 decimal places. Okay, they've told us that if I bought it in South Africa, it would be R8.99. If I bought it in the UK, it would be 79p, which if I convert to rands is 11 Rand 46. You can then see that obviously the South African store is a lot cheaper because South Africa is R8.99, whereas the UK is equal to 11 Rand 46 once I've converted it to rands. Therefore, South African store is cheaper. And that's the end of that question. Right, question 3.4 is dealing with ratios. This is also a question that's where they've given us the total and we need to work backwards to find out how much each of the parts actually consists of. So if we read the question carefully, it says a chemist needs to make a 360 milliliter mixture. When it says mixture, it means the whole. That's the 2 parts added together gives me this mixture. It's made up of ingredient A and ingredient B. So basically that means A plus the B is equal to the mixture. Okay, the ratio of A to B is 2 to 4. And my mixture altogether is 360 milliliters. And the question is, calculate in milliliters the quantity of each ingredient the chemist will need. Okay, so our answer needs to be in milliliters. We know the total is 360 milliliters. We need to first work out how many parts there are. If I say 2 plus 4, I get 6 parts. And I need to now share this into 6 parts. If I say 360 divided by 6, I will get 60 milliliters. So therefore, each part is 60 milliliters. But I don't have one part. I've got 2 parts and 4 parts. So I know that A to B, this is 2 parts and this is 4 parts. And I need to now times each of these by 60 to work out how many milliliters each of them is. So 60 times 2 is 120. And 60 times 4 is 240. And together, if I add these together, it should give me 360 milliliters. So now I can say A is 120 milliliters and B is equal to 240 milliliters. And because they add up to 360, I know that I'm correct. That's the end of question 3, and we're going to now take a break. Welcome back. We're going to start with question 4 now, and this one is a little bit more complicated, not in the math side of things, but in the story. You need to actually read it very, very carefully in order to understand what they're actually asking. Sometimes when there's a lot of words, it's easier to make summaries for yourself or underline things so that it's actually very easy to determine what they're actually asking. So let's have a look. Mr. Turner works at the Matchbox company as a foreman. He looks after the machines and is also responsible for checking the quality of the packing of matchboxes. Each hour he selects a random sample, so that's a keyword, random sample of 10 matchboxes, and checks that the boxes are filled with matches. The machine packs 32 matches into each matchbox, and the machine is able to pack 1,000 matchboxes every hour. Okay, so there's lots of information there. Let's see what the questions have to offer. Okay, the first one says, what percentage, so that's the keyword, we want an answer in percentages, of the total number of matchboxes packed in 1 hour. So remember, this total number of matchboxes packed in 1 hour is 1,000. Does Mr. Turner select for checking? So he selects a random sample of 10 matchboxes. So I need to write that as a fraction. So he checks 10 out of 1,000. And I need to now change this to being a percentage. How do I change anything to being a percentage? I times it by 100. And if I had to type that into my calculator, it would be equal to 1%. Right, the next question. There's some more information given to us here. In a particular sample of 10 boxes, Mr. Turner finds one box that is 75% full. How many matches are in this box? So we now know it's 75% full. I now need to go back to my original question and find out how much is a full box, because I need to know how many matches there were to start with. And you see that it says 32 matches. So a full box is 32 matches, and this is only 75% full. So we know that a full box is equal to 32 matches. So I need to now work this out. So I'm going to say 75% of 32. So that's of is times 32. And if we do this on my calculator, it's going to be 75%, remember, is divided by 100, if I don't have a percent button, and then times it by 32. And that should give me an answer of 24. Have I answered the question? How many matches are in this box? Yes, 24 matches. Lovely. Next question. What is the probability? Now remember, probabilities are often written as fractions or decimals or percentages. Of Mr. Turner selecting his box first from the test sample. So what are they asking us? What is the probability of Mr. Turner selecting this box, so the box of the 24 matches, from the test sample? Okay, so remember the test sample was 10 boxes. How many boxes did he select? This box is one box. So the probability is going to then be 1 out of the 10 boxes. Obviously this can be written in a few ways. So it can be written as 1/10. It can also be written as 0.1, and it also can be written as 10%. Right, let's go on to the next part. Still dealing with Mr. Turner, but now there's an extra little piece of the story as well, that Mr. Turner earns 72 Rand 50 an hour, but is paid a bonus if his team exceed their production and the quality targets. So Mr. Turner worked 35 hours over a long weekend to keep the production running, and he was paid a total of 2,675 Rand for his effort. How much was his bonus? Okay, so if we understand this, he has his normal pay plus his bonus to equal the total which they've given us of 2,675 Rand. This normal pay, they've told us he earns 72 Rand 50 Rand per hour, and they've told us that he works for 35 hours. Okay, so 72 Rand 50 times 35 Rand times 35 plus his bonus is equal to 2,675 Rand. Now this part is quite easy to work out. We just get our calculator out and say 72 Rand 50 times 35, and I get an answer of 2,537 Rand. And when I've got comma 5, I always need to add on an extra decimal place because money has 2 decimal places, remember? Okay, plus my bonus is equal to this 2,675 Rand. Right, so basically what I have earned minus what I normally earn will give me my bonus. So my bonus is equal to the total minus my normal pay, which is 2,675 minus my normal pay of 2,537 Rand 50, which when I do this on my calculator is going to give me so 2,675 minus my 2,537 Rand 50. Make sure your decimal places are in, otherwise you're not going to get a reasonable answer. And that is the amount that he actually gets paid, 137 Rand 50. So his bonus is 137 Rand 50. You'll notice on the calculator that it said comma 5, but please make sure that money always has 2 decimal places. So if there is only 1 decimal place showing on your calculator, please make sure you add in that extra 0. And that's the end of this section. I hope that this has been helpful in order for you to prepare for your exams. Please make sure that you go and do those multiple choice questions at the end on your own, and hopefully you'll be well prepared for your exams. 3, 5. And again, timesing comes before adding, so therefore this part would be done next. So let's get out our calculator and do this first bit. So let's do 3 divided by 4 times 16. And that gives us 12. And then I need to do this part. So I'm going to clear my calculator and do 0.05 times 235. And that doesn't give us a very nice answer, so I'm going to do it in decimal form, and that gives us 11,75. When I add these two together, if I add 12 and 11,75, I will get 23,75 as my final answer. Okay, let's go on to question 1.2. Now, when we're talking about percentages, we need to remember that a percentage basically means divide by 100. So what I could do is write my 35% as 35 over 100. Of always means times, and then we've got in basic data handling, this includes your graphing, this includes your averages, being able to compare data, being able to do different things with the data, and then being able to come up with a comparison if necessary. In this section, you need to be able to explain how to work with the best value for money. So they might give you just different examples of different values of things, and then you would need to decide which would be the best option to buy if you were purchasing it and wanted to buy the cheapest goods. You need to also be able to convert into different foreign exchanges, and then also be able to comment or use those different areas of foreign exchange. Another thing you need to be able to do is to actually being able to work with averages. This would be your mean, mode, and median. You would then have to be able to decide which is the best option for the different scenarios, and also be able to comment on these. And then the part that everybody finds difficult is solving problems, and that's what we're going to be doing later on as well, looking at some examples of solving problems. You need to be able to solve problems using ratios, fractions, decimals, and percentages, and foreign exchange and money, and of course our favorite, probability. Let's now look at 2,405 Rand. So I would then get out my calculator. I would then say 35 divided by 100 times by 2405, and make sure it's in decimal form so I can write it as money, and should give me 841 Rand and 75 cents. Please always make sure that money has only got 2 decimal places. Right, let's go on to 1.3. If 5/8 of a pizza was eaten, what fraction is left? Now, if I can imagine my pizza and I cut it into 8s, and I've eaten 5/8, it would be very easy to then see I've got 3/8 left. But how would I do this on a calculator, or how would I do this when I actually haven't got an easy number, for example? Just look at some examples, and let's see how we would actually go about answering them in the best possible way. Let's start off with a few easy ones to start with. Now, I'm going to be focusing on the fact that you might not have a scientific calculator. If you have a scientific calculator, obviously it's a lot easier to actually do this, because you can then just plug it in and it looks identical to this in your calculator. So if I pulled up the calculator, it would then tell me step by step. I could just type this in with the brackets and put my fraction in and push the equals button. So then it's not very, very difficult. What I want to focus on is that if you didn't have a scientific calculator, how would I then go about doing this? And this is where we need to remember our friend BODMAS. B stands for brackets. This one stands for order, which is basically your power, if it was to the power of 2 or something else. This one would be divide, multiply, add, or subtract. So in this situation, I would look and see, oh, I've got brackets, so I'm going to do this part first. If I had to type this onto my calculator, I would type it as 3, and I don't have an over button as for fraction on my basic calculator, so I need to remember that the 4, if it's 3/4, it means 3 divided by 4, and then times by 16. And I would do that part first. Then I would add, then it'd be 0.05 times 2. Hello grade 12s, today we're going to be doing some revision, and we're going to be focusing on maths literacy and calculations with numbers. Let's first of all start by looking at the checklist of things that you need to know before we start revising. You need to know how to work with fractions, decimals, and percentages. As part of this, you need to be able to identify parts of fractions and decimals. You also need to be able to add, subtract, multiply, and divide these decimals, and remembering the key of BODMAS rules. We will also be looking at increasing and decreasing by fractions and decimals and percentages, and comparing using fractions, decimals, and percentages. You will need to be able to work with ratios and work with large and small numbers. This is a very important one, being able to convert units of measurements. There's some key ones that you need to learn and others that will be given to you, but we'll talk about those in some of the examples. You will need to be able to convert different currencies given the exchange rates. And one that most people find very difficult is being able to work with time and be able to convert between the different parts of time.